Hi, everybody. I'm Naureen. I'm the CEO of Meshcapade. We're revolutionizing the creation and the animation and use of 3D avatars across multiple verticals. But before I get started about the talk, I just really wanted to mention two things at the beginning. First of all, this is the best stage that could ever be used for such an occasion. Planetariums, coming to planetariums as a child was my favorite thing. And it is also the place that inspired me to get more involved in 3D visualizations and astronomy, but mostly how to visualize things in such a, at such a large scale. Second thing I wanted to mention was, Owen, your talk was awesome, and the kinds of regulations that you're talking about are exactly the reason why we, as a company at Meshcapade, we are a spin-off from Max Planck Institute, and those kinds of things are what we need to support and grow, and that's exactly why we are founded here in Germany, and we're proud to be a German startup. Okay. Thanks. All right. Let's get into it. The age of avatars is coming. What does that mean is that digital humans will power e-commerce, telepresence, social networking, and gaming, obviously. And we'll need different kinds of avatars for different kinds of uses. So we'll need highly accurate digital doubles of ourselves for shopping for apparel online and e-commerce, and even for health and fitness needs to make those spaces more digital. We'll need photorealistic digital humans for virtual presence and for meetings, where the world is going right now. And then we'll obviously need fantasy characters for entertainment and games. But there's something missing. A technology that can easily and quickly create digital humans. And it's missing because there are many barriers to this. First of all, capturing the 3D motion and the body shape of real humans realistically and quickly is really, really hard. And that's a challenging problem. And then, of course, right now, there are the only super realistic characters that we see are in movies or in games. And those actually right now take months of work of Hollywood creators and animators and teams of them working together to create those over several months. So these are the problems that we're tackling through Meshcapade and also making it possible for everybody else to solve together. And we've built the core technology that brings the digital humans into the hands of everybody else. We combine computer vision, machine learning, and AI to create the digital human layer that's underlying the synthetic data, e-commerce, and the metaverse. Digital humans are a part of our future. This will actually change how industries work, it will in fact create new kinds of industries. At Meshcapade, we're building the tools that will bring these core digital human technologies and AI technologies into the hands of everyone, from artists and creators to e-commerce businesses and apparel designers, and all the way to people working in the healthcare and fitness spaces as well. So that everyone in any space, they have the same tools and this foundational models for digital humans that they can build themselves on top of. So now let's get a bit more into the details of how all of this works. So we've all seen a lot of these rapid advancements in the AI space with generative models and diffusion models and so on. So the key question here is, why is everything just limited to text or to 2D images? Well, that's because diffusion models, they can make beautiful 2D images, but they can't generate 3D data, or they can't generate realistic digital humans in 3D because there just is not enough data, 3D data, for them to learn from. So for that, what we need is a way to create large amounts of this data for training these kinds of models. And for that, we need to first capture the 3D information of how we move, how people move, how they look in their real lives, and how we interact with each other, or how we interact with the different objects around us, and the general world around us. And there's another piece missing here. just having large swaths of 3D data, just large data sets of 3D scans or motion capture, that's not enough on its own. Like all mathematical models, like even the diffusion models that you see here, like with the DALI and such, this data needs to be in a consistent format. Just like images are always in a consistent 2D format, a two-dimensional grid. All of the 3D data of the world has to be in a consistent format that can be turned into a matrix that the computer will then be able to understand and learn more details about being able to generate realistic humans from. So, and that's the core problem that we are solving with our startup. The answer is simple. That's a pun, yes, SMPL. We named it on purpose. Simple is our patented generative body model. Simple captures the nuances of the human body shape and how we move, including facial details and facial expressions, soft tissue deformations, as well as hand motions, everything in 3D. So we trained this model on over 1 million 3D scans and millions of frames of people, of motion capture data of real people. And from that, we converted all of this information into a consistent representation that can be used to train any kind of AI network. So essentially, we've turned this information, the 3D information that we collected about real humans, into an equation where now we can just recreate or regenerate any person of any body shape in any kind of motion with just numbers. So that's really making solving that mathematical problem. So with this, we also made it intentionally completely free for academia. So that was where our Max Planck connection comes in. And we made it for academia as well as the creative communities, because this provides this foundation for so much more that can be done in the AI space, and having more people have access to it gets us much further, much faster, and builds a community around it. All right, so what can we do with this? With this model, we can easily use it to train neural networks to generate 3D humans from any input. The input can be just images, or the screen is here for you guys. It can be just images or photos. It works for any body shape because the model itself has learned to understand the variation that exists in human body shapes and the poses that humans can assume. So it can easily regenerate any person in 3D. Or we can take a standard video, like this one from YouTube, and we can compute the 3D human motion together with the full body. The input can even be just text. This is why this simple model is in fact already the de facto standard for deep learning and AI methods in academia and the industry today, because it can create this one consistent format of 3D humans that can be then connected into any AI model for any kind of input and for any kind of use. So, and with that, what's the next evolution with 3D humans? Neural appearance. What you see here is actually not a video. These are 3D models, which we call neural avatars. So this is essentially a neural network that has learned the complexities of clothes and hair, and it's painting that as a neural layer on top of the simple model that I've been talking about. And this information it's learned from data, and learned from video, and because of that, it's lifelike by design. And once again, as a base, it's using the simple model as the base, and the foundation for creating this underlying layer that can be then animated with just text, or from other video sources, or from motion capture sources. With that, now that covers the whole of all of the technology that we've been building towards. With that, I would like to wrap up with the digital human possibilities and talk briefly about the future technologies like ours and what it means for all of the different industries and us all in this room. As I've mentioned above earlier, every vertical in this, every vertical market here, they have a need for digital humans today that needs to be solved for them to become more capable, have even further capabilities within the digital spaces. And right now, in each of these industries, as well as in academia and in the creative spaces, the solutions that exist to help people create digital humans are really limited because they're focusing on just one piece of the human. They're either just focused on creating, accurate shape of a person, or they're focused on creating just an the accurate motion of a person, or there are solutions that are just focused on building synthetic data, sometimes without a real grounded, understanding of real humans. And then there are some solutions that are just focused on stylization, on creating stylized sort of, characters. So we can power the needs of everyone within this, whole landscape, so to speak, with just one core technology that's built to generate a full human instead of pieces of what humans look like, or how humans move, or how they interact with the world around them. And that's essentially the core solution that we're bringing. We're bringing together the capabilities of everybody in this space, all the individual solutions, giving them all a consistent foundation, a standard model for their own digital human solutions, regardless of whether these solutions are in the academia or the creative sciences or creative spaces, or whether it's in the industry. And that's essentially what we need to build as a community as well. We need to build more open technologies right now that lay the foundations, bridging our actual physical reality of the real world with the digital spaces so that it becomes more approachable and more reachable for everybody in this space at an equal footing. All right, and that's it. I kept it really short because I was told many times. So this is what we're working on, building the future. Thank you.